All right, guys, welcome today. Hope you had a good weekend. We are going to be looking, and we are starting something brand new today. So we are going to be looking at multiplying a whole number times a fraction. Now, let's talk about this for just a second. We are going to be on page 242 and 243. Let me also get that one out as well. So 242 and 243. All right, so let's discuss this for a second. Let's talk about this. So we just got done multiplying. And what do we remember multiplying, right? We remember multiplying, we were multiplying two numbers together. Our product or our answer gets bigger, right? It's something that gets bigger. Today, we're going to look at multiplying by a fraction. And we're going to see, is it equal to our whole number? Is it smaller than our whole number or bigger? You might say, wait, how can it be smaller than our whole number? We're going to look at that here in just a second, okay? So let's look at this sheet right here. We're going to do some of this together, and you guys are going to do some of this with your teacher, and then some that you are going to create as well. Okay, so we're going to start with, we are looking for, is the product less than 2, greater than 2, or equal to 2? We're going to talk about the rule of how we're going to figure that out. Okay, so we're going to be multiplying by 2 on each of these. So let's start with the equal to 2. This one's the easiest. So 2 times something is going to equal 2. Now you might say 2 times 1. That is correct. 2 times 1 is correct. However, we're looking for a fraction. We're looking to multiply by a fraction. Remember, a fraction has a numerator and a denominator. And we're looking to multiply by a fraction that's equal to 1. Anyone think about a fraction equal to 1? I'll give you a hint. It has to be the same number on top and on bottom equals 1. So let's multiply 2 times 3 over 3. Let me zoom in a little bit so you can see that. So I know that 3/3 is equal to 1 whole. Well, how do I know that? Well, if I break something up into 3 pieces, and I shade all 3, I've shaded the whole thing. So that's equal to a whole. So this is like saying 2 times 1. So this is going to be equal to 2, right? 2 times 1 is equal to 2. Let's try another example. What about 10 over 10? Well, if I split something into 10 pieces and shade all 10, that's the same thing, equal to 1 whole, right? It doesn't matter how big the number is, as long as the number is the same on top and on bottom, is always going to be equal to 2. I can do the same thing. And let's do 100 over 100. That's also equal to a whole, right? So if I were to break this circle into 10 pieces and shade 10, or 100 pieces and shade all 100, that's still equal to a whole. So all of these, this is going to be equal to 2, 2, and equal to 2, okay? So no matter what I'm putting here, all my fractions are equal to a whole, so this is gonna all equal 2. So no matter what I put here, as long as my fraction equals 1, it's going to be equal to 2, because all of these are 2 times 1, 2 times 1, 2 times 1 with my fraction, okay? Let's talk about something that now is less than 2. So I'm gonna shift this over, something that's less than 2. So I'm gonna once again start with 2. Now, in order to find something less than 2, I have to find a fraction that's less than 1, meaning my numerator has to be smaller than my denominator, okay? So let's try, instead of 3/3, let's try 1/3. So that would be like if I were to shade one piece here, okay? So this is basically telling me I need 2 pieces of 1/3. Okay, 2 pieces of 1/3, so this would be equal to 2/3, because it's 1/3 and 1/3. So it's 2 pieces of 1/3, and 2 pieces would be 2/3. Okay, let's try a different one, and then let's try something that we can use to solve. How about 2 times, let's do 5/10. Once again, smaller number on top, bigger number on bottom, so it's going to be equal to less than 2. Now here's a cool little trick that you can do. Look at my equation right here. What I can do is I can, to make them look the same, I can add a 1 underneath, and I can then multiply my top numbers and my bottom numbers. So these two and these two. So if I do 2 times 5, that's equal to 10, and 1 times 10 is equal to 10. And what do we know about 10/10ths? We said already that 10/10 is equal to 1 whole. Okay, let's do another example that's going to be less than 2. Let's do 2 times, let's think of a fraction that could be less than a whole. There can be any fraction that's less than a whole, smaller number on top and bigger number on bottom. Let's try, let's try something that's close. Let's try 9/10. Okay, let's do the same thing we just did. So in order for me to solve this now, I could just add this up twice. Just like I could have added this up twice, and multiply by 2, or I can try to put my 1 underneath and multiply. My 1 underneath, 2 times 9 is equal to 18. 1 times 10 is equal to 10. Now, this is an improper fraction. So I have to ask myself, how can I make this into a proper fraction? Well, I know that 10 goes into 18 one time with 8 left over. 11, 12, 13, 14, 15, 16, 17, 18. 8 left over, 8/10. And that's also less than 2. So look at all my answers. 2/3, 1, 1 and 8/10, they're all less than 2 because my fraction is smaller than a whole. So let's see who's been paying attention. If this has to be equal to a whole, this has to be less than a whole, what do you think the fraction needs to be in this column to be more than 2? It's got to be bigger than a whole. So it's got to be an improper fraction. My numerator is going to be bigger than my denominator. So let's take a look at this one. All right, so start with 2. We're multiplying by 2. 2 times, and let's make a bigger fraction an improper fraction. Let's multiply by an improper fraction. How about 6/3? Right, my bigger number now is on top and my smaller number on bottom. So let me go ahead and put my 1 underneath and multiply. 2 times 6 is 12. 1 times 3 is 3. That's improper. So how many times can 3 go into 12? 3, 6, 9, 12. 4 times? Oh, look, my answer is bigger than 2. My answer is bigger than 2 now because I'm multiplying by an improper fraction. Let's multiply by another improper fraction. How about, let's do a weird one here, 12/10. Kind of a strange one. Let's try 12/10. All right, let's do my strategy again. My 1 underneath, make them look the same. Fraction, fraction. Remember, this is still 2. I'm not changing anything. I'm just putting a 1 underneath. It still makes it 2. I'm going to multiply, or I could add this up twice. I'll do that for my next example. So 2 times 12 is 24, and 1 times 10 is 10. How many times can 10 go into 24? 10, 20, 30. Ooh, 30 is too many. 10, 20. 2 times with 4 left over. And remember, my leftover is my fraction. All right, let's do one more example. 2 times, let's try, how about 8/5? So this time, instead of putting our 1 underneath, let's just add this up 2 times and see if we can get our answer. So 8/5 plus 8/5. Now remember, let's see who remembers from 4th grade. When I'm adding fractions, I add my top numbers, so that's going to be 16. But what happens to my bottom numbers? I don't add my bottom numbers, it stays the same. We remember that from 4th grade? It stays the same when I'm adding fractions. So my answer this time is 16/5. That's improper, so let's think, how can I make that into a mixed number? 5 can go into 16, 5, 10, 15, 3 times, and then 1 left over to get to 16. So 3 1/5. And look how that's over 2. So let's recap, because now you're going to make and you're going to create some samples in your box with your teacher, and then you're going to do some on your own. Okay, so in order to be equal to 2, notice how every single one, guys, I multiplied by 2. Every single whole number is 2. It's what I'm multiplying by that makes the difference. So this one, all of these numbers are equal to 1 whole. 3/3, 10/10, 100/100. These 3 are all less than a whole. They're a fraction. They're a part of something, right? So for example, this 1/3 is just one piece that's shaded instead of all 3 pieces, it's just one piece, okay? And then these are kind of the weird ones. These are all improper fractions, meaning the numerator is bigger than the denominator. But that makes my number bigger than 2, okay? So you're gonna now do some examples with your teacher here, and then you are gonna create some on your own and solve them here at the bottom. Then when you finish, you got this as independent work. For each of the expressions below, tell whether the product would be less than, greater than, or equal to the whole number in the expression. Explain your reasoning. So now you're looking at 4. So is this going to be bigger, smaller, or equal to 4? Bigger, smaller, or equal to 4? Bigger, smaller, or equal to 4? And use the same strategy. Am I multiplying by 1, a whole? That's going to be equal. Am I multiplying by less than a whole, a fraction? It's going to be less. Or I'm multiplying by an improper fraction, it's going to be more. And explain that reasoning down here. So solve each of these and then explain your reasoning down here in your journal. All right, good luck, guys. Go ahead and work with your teacher on some more example expressions, and then you can work on your independent practice for today. I'll see you guys tomorrow.